Okay, so basically we are going to show you a factory workflow, but we will also show you the so-called brownfield design with factory. So when you design a factory in an existing building, that is a quite common case, but also how to communicate between the stakeholders of the factory design solution. And, sorry. And yeah, and then Matt at the end will also present you some solution for the factory of the future, but that are already available today. So I will present in hopefully 15 minutes the so-called 1D to 4D journey. Okay, so when we plan a production line, an assembly line, in general, the problem is the space. So we need to understand if our production line, the assembly line that we have in mind, will fit in the space available. And of course, we also want to be sure that we can reach our production target, daily, monthly production target. And the best way for starting this is with a simulation. Today, in 90% of the cases, the factory layout is created just in AutoCAD 2D, but the factory design is a very complex project, so with 2D we cannot really check all we need to check for such complex project. Also, we have issue in communicating between the different stakeholders. So today, again, we are going to talk about a complete solution, the so-called digital factory solution, that goes from the 1D, so from the process planning to the 2D, 3D layouting, up to the 4D, so the timeline for my process. Two things that I want to clarify: this is not a mandatory workflow, so you can stick in the D you like. You can use a couple of D. And another things that I want to clarify is that probably some of you, or maybe most of you, don't do factory design. So why should I care? Actually, I mean, the factory design utility basically allow you to use the, I think, well-known AutoCAD block concept, but to use it in 3D. So basically, you have your assets that you can snap together for rearranging any layout, so not necessarily a factory, an assembly, a production layout. So for instance, we have customers that use those utility, customers that create furniture for school, so they need to check if their product fit, depending of course the architectural space can change, retail space, supermarket, so where should I put the shelves, the freezer, and so on, exhibit booths as well, and also shipbuilders, so for shipboard compartment layout. So it's not just for so the name can be misleading, factory, but I mean, you can use those utilities also if you don't design factory. And again, the 1D to 4D workflow is not mandatory, but today, now I need the other end. So today, basically, we are going to show the complete workflow starting from this dataset. So this is basically an existing factory where I want to set up in one of the building a welding cell for basically welding basically the sheet metal from those tractors that you can see here. So this is basically the purpose of what I'm going to show. So the 1D, is the virtual setup of the process to check and verify if I can obtain the required product at the end of the day. So far, we do that with a material flow, like in this case. We can also use Excel sheet that contain the properties of the assets that we are going to use in our layout, but those are all broken process, so they don't talk to each other, very manual. While with process analysis, that is one of the factory tools, basically we can create a process, we can simulate a process with data, animate it, so we can simulate basically if we have hiccups, if we need bigger buffers, what happens if a machine fails for a certain amount of time, and we can check everything before even to draw a line, and of course before to set up physically anything, and then realize that there is problem, there is things that we have overlooked, and so we need to do some costly change. And this of course apply also if we need to modify our production line, our assembly line. So with no downtime, we can just simulate the impact of the changes and then just apply the changes when we are happy with it. So let's see this in action. So of course I can start creating my schema manually. So basically driving my blocks. Like this, it's very straightforward. But so just to show you that it's a product that it's very easy to use. But of course, for complex process, this is not really ideal. So I'm going to show you a smarter way to work with this simulation tool. So in this video, we can see that I can import basically an Excel file in this tool. This Excel file can contain all the properties of the assets that I'm going to use in my factory layout. So the data basically are compiled by the machine engineer, so real data, so the simulation can be really precise. And now you can see in action basically what I call the backbone of the factory utilities. So basically the factory library. So it's a library that contains all the 2D and 3D information for the asset that I'm going to use in my layout. And I can already start in the simulation phase to map the station of my schema with the right machine, as you can see in this case. Again, those stations will have already the properties that I've imported from the Excel file, but in process analysis I can still modify, change, or add other properties. So for instance, in this case we have a station where I'm going to assemble my sheet metal before welding them, so I need a merge option. Then the welding will be a sequential operation, so I need a sequential property, and then I'm going to simulate how many components I can produce, for instance, in 8 hours. And then, for instance, in this case, the quantity that I produce in 6 hours with this schema, with those properties, is not what I was expecting, so I need almost the double. So I can just duplicate the welding cell in the simulation phase, as you can see in this video. Or basically, I got the message that I need basically another welding cell, so I can do this when I move from the 1D to the 2D, as we will see afterward. But in this case, okay, I can very simply copy and paste the welding cell, reconnect it with the other blocks, and then rerun the simulation. And then if the quantity produced is what I was expecting, and I cannot optimize the process further, basically, so I'm happy with that. I create a report with all the details information about the machine utilization and other information. This report, of course, can be shared with the stakeholder of the project. And then finally, I export my simulation as a DWG file. And after that, I can go basically to the this was the simulation, the 1D, and then I move in the 2D. And basically, this is what is the result of my simulation, the welding cell that contain already the asset that I have inserted already in the simulation phase. So the assets, some additional information about the assets that, as I said, is the backbone of the factory utility. So you get assets, a huge amount of assets for different applications, as you can see on this slide when you install the factory design utility, but you can create and publish your custom assets. The asset can be stored locally, can be stored in a folder that is basically managed in the definition of an inventor project, can be stored on the cloud, and of course you can manage those assets involved. Okay, so this is my existing 2D layout where I want to insert the welding cell that I have simulated. As you have seen, I have exported it as a DWG. Okay, so I basically inserted just inserting the DWG exported from the simulation as an XREF. So in this case, I have just one welding cell. I know that I need a couple, so I just duplicate it with the standard AutoCAD tools. And then I'm going to position the welding cell where I want basically to install it. And then using the same library that I've started using already in the simulation phase, I can keep on adding assets from those libraries. So in this case, a cable tray that connect the controls. The cable tray, of course, is hanging on the side. So I can add, even if I'm in 2D, I can add an elevation. Then I can add conveyors. I can add any other assets that I need in my layout. By the way, and this is the traditional 2D parts, right? Now, at this point, in my story, the 2D part is over. As I was saying, nowadays is basically 90% of what, in general, the customer do. So they just create 2D layouts. But for me, the 3D, it's much more powerful. So, as I will show you in a moment, with a single click, I can convert the 2D layout in 3D, and I can keep on working in 3D, where I can keep on adding assets, very easy to insert the assets, to place them, and I can still I can always keep in sync my 2D layout with all the changes that I'm going to do in 3D. So everything that I do in 3D, I can sync this back to the 2D and vice versa. So I can keep everything in sync. But since I believe that the 3D is much more powerful, I will work mainly in 3D. So from the 2D layout, with one click, I will get something like that. So still in AutoCAD, I just need to click for syncing everything to Inventor, and all the 2D asset will be converted in the corresponding 3D version. And then again, using the same library, now in 3D, I can keep on adding assets, like the cranes for taking the stuff from the conveyors, for instance, and you can see that it's very easy to position and those assets. Okay, and basically, I will end up with something like this in Inventor. And for the one of you familiar with Inventor, so this is basically the welding cell that I will start simulating in the 1D environment, moving everything with one click from 2D to 3D. I will get the bill of material of my welding cell, so with all the components listed in my bill of material. So those are the assets that I've already inserted in the simulation phase. And for instance, this is a custom asset. When I publish my assets, I can add the script, a description, and the description can also contain, for instance, an hyperlink. So in this case, I can click on the hyperlink and I can open the datasheet of the machine that I've inserted in my layout. Of course, I can create 2D representation for the documentation of my welding cell. And also in 2D, I can in 2D, I can create the part list. I can balloon. Okay. So, and I have basically all the detailed information from my documentation, and this is simply the welding cell that I have started in 1D. Okay, but as I was saying at the beginning, in most of the cases, I'm going to do installation in existing building, and of course, I want to see if, what I'm going to implement is going to basically collide with the existing building. And for doing that, I can create a scan of the existing building, and I can import this scan in Inventor. Before doing that, and Nate will talk more about that, I can edit my scan in Recap. For instance, I can create region so that basically I can just display the part that I need to display. And as I said, of course, I need to check the collision. That's the main things that I want to check. And also in this case, with a single click, I can move from Inventor to Navisworks. I won't do this for time's sake, but once I have everything in Navisworks, I can do many things. I can do walkthrough. I can create viewpoints. I can climb on stairs because the tool recognizes the obstacles. But in this case, what I want to do, for instance, is to check if the the point cloud, so basically the point cloud that represent the existing situation collides, for instance, with the crane that I've inserted. So for doing that, I can, there is a tool that allows me to do that. And basically, in this case, I will check if the welding cell that I have inserted is going to collide with the point cloud. Something to notice is that the tool does not consider the point cloud as a huge entity, but basically detect region inside the point cloud. Okay, so in this case, the crane collides with the existing structure. Of course, Navisworks is a mock-up, so I don't have the parameters inside Navisworks, but there is a command in Navisworks switchback that allows me to go back to the tool, in this case inventor, change the parameter for the crane, and then I go back in Navisworks and I check that basically the collision is solved. That I can do this also with the other collision. And finally, this is the end of my story before handing over to my colleagues. So the 4D is, of course, the time. So I can basically define which component will be implemented on a certain time and date. And I can do this manually, as for the simulation, with the simulation tool, but I can also use Microsoft Project or Primavera that are managed by project manager. I can import them, and I can basically associate the component that I'm going to install, to set up to that. And then in the end, I will run the simulation. I can record the simulation that report basically the date of the implementation. And again, I can share this with the stakeholder, with the other stakeholder of the project. And talking about communication with the stakeholder, then I can move, if I want, my 3D model from Navisworks to a mobile device. For instance, I can import it in a mobile device using an application like BIM 360 Glue. So also in BIM 360 Glue on a mobile device, I can do walkthrough, I can take measures, and yeah, and so on. I can create also a nice rendering, a panorama rendering, 360 panorama rendering of my factory. I can do this using the resources on the cloud. So I can basically send everything to the cloud, and I keep on doing my work while the rendering is happening on the cloud. And when the rendering is done, I get a notification with a link that I can again share with the stakeholder. And then finally, if we want to talk about a level up with the virtual reality, I can allow the stakeholder, but maybe also the customer that has commissioned the design of the factory to work inside the factory as if the factory was already built, but actually is just a digital factory. Hopefully we will be able to show you this. We have some technical issue, but I don't know if you have any questions so far. We will have some time for questions at the end. Otherwise, I would like to hand over to Nate, who will talk more about the reality capture for factoring, but also in general. This picture.
Yeah, there we go. That is not. All right. So yeah, I'm going to do it from here, but it looks like it's presenting. Ooh. It was presenting okay. There we go. So yeah, I'm Nate Moore, and like Alessandro said, I'm going to talk to you a little bit about not virtual reality. Virtual reality actually isn't looking so much like it's going to happen since he's not here, and we don't know where he went. But anyway, there's supposed to be a fourth. We've got Matt here, but we don't have our missing piece of the puzzle for the VR stuff. We can talk about it a little bit, but we definitely don't have his content. But on the reality capture side, I'm just going to show you a little bit of what's possible really quickly, really easily inside Recap here and how that feeds through into the factory piece of the process. So nothing super exciting. Before I get going, though, how many of you are routinely scanning your sites and projects or facilities, any of that stuff? Okay, so a third maybe. Everybody else, you have an idea of what point cloud is, where it comes from, all that good stuff? Okay, great. So for those of you who aren't doing it already, it is not a super high barrier to entry. It used to be really challenging to make it all come together, but these days there's tons of contractors out there. If you want to do it yourself and start to do things in-house, I mean, this will get you going. It's not the high-end, super expensive tools that you run into other places, but in the scheme of things, it's relatively cheap. It's pretty easy to try it out, and it'll do a lot of the jobs that you might need. It's not going to do everything. So it's definitely getting to be something that everybody can think about doing. And what's that? Mic higher? Okay. Is that better? Okay. So yeah, you should at least explore the concept, because what you get out of it is a lot more detail about your existing conditions. And as it gets cheaper, we're reaching the point where you don't just have to do start and finish. You can do midway scans if you're talking about long-term projects, things like that. If you're looking at moving pieces of your assembly line around, you can also look at scanning particular pieces and having those become your inventor assets. So it's not just a standalone thing that you just look at in Recap and the process ends there. So there's a lot of options, whether it's on the internal side, whether it's on the asset side for inventor, or I'll show you a little bit at the tail end of my brief bit here about bringing it into the bigger context, and maybe you need to look at doing site expansion, something like that. It fits well, and it plays well across all the products. So anyway, this is, I think, a chunk of that same scan that you saw from Alessandro. And I just want to show you some of the really simple manual cleanup tools that are possible here, and then we'll jump out to a different project and show you some of the stuff that's a bit more automated, where it gets interesting in terms of taking out moving features, things like that. So Recap in itself, have you all tried Recap? Okay, so we've got a few at least. You didn't raise your hand, I know you've done it. But it doesn't really have a ton of features. You can see it's not like massive menus of options here. And a lot of these are just the sort of getting started sorts of things that are super simple. Just visualization, that's a lot of what Recap does really well. You can go in and manually delete pieces, which I'll show you that, and creating regions. And that's just a question of managing it down the road. So, and as I go, if you have questions, feel free. So here we're just going to look at the color view, but you saw the elevation view there a second ago. And otherwise, super simple controls and really limited features. This particular scan, if you look at it, it's already been cleaned up a bunch. You can tell that because there's nothing on the interior. And it came in as a single scan because somebody cleaned it up elsewhere, and we just have this one big chunk of scan. So because of that, it's not structured. We just have this set of point clouds. It's pretty lightweight, but you can't do some of the other things. So You can see I'm running Pro, but nothing that we show you today actually requires the Pro. That's just when you get into the registration piece of things. And registration is when you have a collection of scans and you have to bring them all together into a single unified scan. So in terms of creating regions, you can do it a couple ways. You can actually do it, I'm not going to show, in Navisworks. If you're Navisworks users, you can actually create regions inside Navis, export those regions as a CSV, and bring the CSV into Recap. A lot of people do like that method, but it's a little more involved, so I'm not going to show you. But if you're already putting everything into Navis, it's not a bad way to go. In terms of this guy, I'm just going to do a simple little one here, manually create let's see, I'll just do a window-based region here. You can see this is a factory, but we've got a chunk of, in the upper left there, it's like a break room or an office or something. So I'm just going to separate that out like so. And it's not a one stop and you're done kind of a setup. So for that one, I'm going to do a new region. We'll give it a name, I don't know, I think it's an office. So we'll just call it the office because we're not going to care about that when we're looking at the rest of the factory facility. So you can see immediately it's the active region. You can see what's in it, what's not. The way that Recap works is when you do these window selections, it's an infinitely long kind of a plane. So you do have to be a bit careful when you're doing your windowing. On a big site, you probably want to reduce it down into smaller chunks first, because otherwise you're going to be picking stuff that's 100 yards away and you don't even realize you're grabbing it. In this case, it's a more limited one. So I'm going to do another window, and you can see this is still active here, what I previously selected. And we can come in and just assign that into the same bit, and that's all going to become part of that. So you get your visualization of the entire region is here, and you can turn things off actually so that you get them out of the way, and they can still have pieces assigned to them then. So it's super simple. Just play with it for a couple of minutes, and you'll understand how it all comes together. So you can see that it's a region I've got turned off, and so by assigning that selection to it, it instantly goes out of my field of view, so you know what you're dealing with. So that's one way. If you want to be a bit more precise about things, particularly for me on the vertical, it's really nice to get the roof out of there, because you're always going to pick up ceilings and things like that, floors that maybe you don't really care about in the scope of your project. The other really nice thing is that you've got the limit box here, and by modifying the limit box not by hand, but rather by looking at the actual, say, Z values. So in this case, you can see I've turned off everything below that negative half meter mark, and this is all just on an arbitrary Z, so your Z would have been the Z origin would have been the height of the scanner. So probably I'm actually not catching the floor in that. So I actually can't remember if this one has a floor in it or not. But if you wanted, for me, more often I take the ceiling out, because then you can have that look down from above and really know what you've got in there. So you can simply, if you know your ceiling height is, I don't know, at 5 meters or whatever, you can just manually set that in here, and then automatically it'll chop that out. So you can say, okay, this is all the space that includes the structural and other pieces, or go the other way and bring your ceiling, your base rather, up to 5 meters maybe, and here include everything up to 7, and there you go. There's a chunk that's just going to be your ceiling. And so you can confirm that, create a window that grabs everything in there, and then in turn assign it to your ceiling group. I've actually already done that, so you can see here I called it the roof area, and if we turn that off, it's pretty similar. So I'll turn that back on, and then if we undo the limit box settings, you can see we've got the ceiling all turned off. So it's a lot easier to look down in and see what's going on. You can see in this case it's already been cleaned up a bit. But this, again, it's not like a million feature kind of a tool. What it does really well is bring in your data from a lot of different scanner formats and let you do that, bring it all together. You need the Pro to do the registration, like I said, but for this basic cleanup, you're going to find that it goes pretty quickly. And these regions play nicely with most of the other Autodesk products. So if you're bringing it into Inventor, Revit, AutoCAD, you'll get that region interface. So you can set up the regions in here and then just turn those on and off in the other pieces of other Autodesk tools as you need them. Infraworks doesn't respect them. I think it's the only tool that doesn't respect the recap regions, but it is well, that's just how it goes. Once you've done this, hey, we do get VR today. So as you work through this, one thing to note is you've got a save option, which does do some optimization, especially if you've deleted stuff. It does the optimization, but it doesn't actually remove those point clouds. You've got to do a save as and really do that delete as you go. On a similar note, once you've created these regions, you can delete the region, and that middle option is to just delete the rules that apply to the region, but the other one is to delete the points that are contained in the region. So you do get different results, so just be sure what you're doing before you go through and do anything like that. And the only other thing I wanted to mention in here is that, like I said before, I wanted to show you this in Infraworks. And if you haven't used it before, it actually is a really nice factory tool when you get to the point of the much bigger picture of how everything pulls together. If you're coming from manufacturing, I'm guessing you guys haven't used Infraworks. Anybody? Couple? All right, cool. So it does do an exceptional job of bringing the point clouds in really well, and it actually adds a few point cloud tools that we don't have inside any of the other products, which is quite nice. But just to show you what that's going to look like, so I put this project in here. So if you look here in the background, we're dealing with the same, was that Revit or Navisworks file from that Alessandro had? Navisworks. So you can bring that straight into Infraworks. It does a great job of aggregating. And then I've gone in and added in the same scan right in on top of that. And you can see you get all the same detail, you get all the coloration. That's all well and good. So you really get a consistent visualization kind of a story. And the thing that Infraworks adds, which is going to be more interesting if you're dealing with, say, at the site kind of a scale, there's this terrain tool, which terrain by itself is nice to have. If you've done all the scanning work and you want to know where your real detailed ground is, you can get it without sending surveyors out if you've already had the scan done. But the other thing that it does there, which is nice, at least when you're dealing with infrastructure projects, is it separates your ground and vertical features. So it'll go through a big scan, a site like this with the exterior, for example, and it'll apply some rules and say, all right, this is the surface, these things are all vertical. And then later you can even go through and automatically replace, say, your light poles, your signage with objects from your Infraworks 3D library in place of those points. So they'll be sized and oriented about right based on what is obvious in the point cloud. And then the linear features are really nice as well. So you can use it to pull out curbs, those kinds of features. Even sometimes rails, if you're doing a rail project, you can get the railway. So railings, all those kinds of things you can pull out automatically once you run it through this tool. So, and then the final bit, again, I'm much more on the AEC side, as you can tell, is this option here where you can export just your ground points. So if you're dealing with massive data sets, millions, billions of points, Infraworks will take them in really well, and it'll push them through, and you can export a new point cloud of just the ground points. And it does that segregation between the vertical and horizontal really well. So then if you want to use another tool that's more traditionally used to create a surface, like Civil 3D, you can do it on something that's already had the separation done really well. That's where Civil struggles a bit, but Infraworks does it quite well. So as a data cleanup tool, between Recap and Infraworks, you can do quite a lot, especially for the site-type projects. So that's my bit in terms of Recap stuff, reality capture. We didn't talk about UAVs and drones and all that. There's a way to do all that and integrate it really well. It's a good story when you need to get the rest of your facility. Maybe you don't want to scan the roof. That works well. If anybody wants to talk later, let me know. Otherwise, thanks, and here's Matt.
Yeah.
Thank you, Nate. So while I'm setting up, is there... How about now? Good? All right. Well, that sounded great. First of all, as I'm trying to set up here, is there any questions for Nate? Press number 7 if you All right, everyone. Thank you for attending our session this morning. My name is Matt LeMay. I'm an Enterprise Solutions Lead, and I focus on additive manufacturing. So to kind of tie the Factory of the Future presentation together, we want to talk about what can we make if we could truly make anything, and that's what additive manufacturing allows for. So just prior to presenting, just a show of hands, who here has experience with 3D printing? So a lot of people, that's good. Who has experience applying it professionally with production? All right, so no one. Great. So when I make these presentations, I typically ask, what is the first thing that comes to mind when you think about 3D printing? And for a lot of people, it's still the concept of prototyping. So 3D printing has been around for a long time, and the materials are pretty limited. Some of the failures that you see here on the left is probably something that a lot of you have experienced as well. So when you add all of these things together, like the need to remove supports, large minimum feature sizes, lack of materials in conventional 3D printing, it can have a pretty limited value to you and your business. So 3D printing is changing very quickly, and we need to start looking at how a lot of the new techniques can actually start applying to production. So it seems like every 3 to 6 months there's a brand new 3D printing technology, and that allows for us to print with brand new materials at new speeds, at lower cost. So now we can look at making things that have very small feature sizes. We can look at using additive manufacturing without supports. And when we start adding all of these values up together, additive manufacturing within production is where we can truly gain the competitive separation. So I'm sure we've all heard the hype of the 3D printing market. There's probably lots of presentations that you'll see throughout the week on 3D printing. There's a lot of 3D printing components that you'll see throughout the exhibit hall. We see throughout the industries that each one is growing rapidly, whether it's the aerospace or automotive or consumer products. So, we've always thought about additive manufacturing as maybe it's just going to be in the aerospace industry. Within the next few years, we really see it moving outside of just that. And some of the market research that we've seen is that we're expecting anywhere from 34 to 95 times growth within the industry. So there's certainly a lot happening here. So we need to really understand why that growth is happening and how you can apply it. So with additive manufacturing, we look at 3 main advantages that you can yield. The first is that we can consolidate our assemblies. So there's some really good examples of how we can take complicated assemblies, improve our supply chains, assemblies that were once 20 components, and then make it to a single component using additive. The second would be not just to reduce weight, but to improve product performance. And we'll talk about a couple techniques and how you can do that as well. With additive manufacturing, we're reducing a lot of the conventional constraints that you've had with your production processes and allowing you to make very unique forms that you haven't in the past. And then the third, and this is the one that I think is really the most important, is the idea of the mass customization. So none of our consumers are exactly the same, and none of our products that we sell to them should also be exactly the same. So we've always had economies of scale, a small, medium, or large, just so we can make profit. But with additive manufacturing, we can make a unique component every time, and that's where we can really get the competitive separation that we need. So throughout the presentation, we'll talk about 2 main things that you need to accomplish to really receive the advantages of additive manufacturing. The first is product optimization. As additive manufacturing can be significantly more expensive, we need to put in more performance into our products. So we'll talk about a couple ways to do that. We also need to link that with an optimized process as well. So it's not enough just to think about what the optimal component would be. We also need to come up with the right process that we can actually create that at the scale that we need for our company. So for the first piece, we'll talk about how we can add performance to our products. So with conventional manufacturing, as we add more complexity to our parts, the price continues to rise. So we've always had to make products that are heavier than they need to be, that they might not look as great as we would like them to, but we've made those compromises just for the production process that we have. So with additive manufacturing, for the most part, the more complexity that you can add to a part, it's the same price. So you can see the part on the top we knew is heavier than it's heavier than it needed to be. It doesn't look as new as it needs to be, but we've made it that way for the production process. So with additive manufacturing, we can truly unlock levels of complexity that we haven't seen in the past. And there's three main techniques that we'll cover throughout the presentation today of how you can start really unlocking that product performance. The first would be topology optimization, lattice optimization, and then the idea of the generative engineering, which I'm sure you'll hear a lot about throughout the week. So the first example, and this is one that I always show, because this can apply to not just additive. So just a show of hands, has anyone here used either Inventor or Fusion 360? So it looks like pretty much everyone. So this kind of technology is currently available in Inventor and in Fusion 360. So it's something you can start using now. The idea is pretty simple. So we apply our loads and constraints to our part. We apply some information on our manufacturing process, like what the smallest feature size that we can produce would be. And then we allow it to resolve what the ultimate component would be. So the resulting part is probably not something that we would have even thought of in the past, that it can result for us, since our conventional production processes haven't allowed us to make those kind of forms. So it's important to note again that topology optimization and the shape optimization ideas are not just unique to additive manufacturing. So when I had the show of hands, there was no one using additive manufacturing within production, and that's certainly fair. It's new. But we can use a lot of these ideas to help us tie into conventional processes again. So you can see from 1 and 2, as we move to 3 in the topology optimization, we can use the results of that to tie it back into something that we can make with a more conventional process. So just to show an example from one of our customers, and this is that same part that I showed when we were talking about the complexity that we can have within our products. They've had a very conventionally manufactured part for a long time, and again, they knew it was heavier than it needed to be. The main advantage, or the main challenge that they had, was they had to make these nodes at 1,600 unique forms, so every one had to be unique. And that's something that's pretty much impossible using conventional processes. So the first thing that they looked at was how much weight can they reduce from their component using really the shape optimization that we were talking about. So it's applying the loads and constraints, finding out where it needs the material and where it wouldn't, and then resulting with the ultimate component for that process. So then you can see again, this is something that's completely unique from what they had at the beginning, and it's also something that now they can make every single one of these very unique. So the second piece is lattice optimization. And when we talked about topology optimization, that's not something that's unique to additive. We can work with that to bring it to more conventional processes. With lattice optimization, it pretty much is unique to additive. So with lattice optimization, we're still applying our loads and constraints to our part. We're more interested in changing out the internal structures of our component and applying a lattice structure to it. So you can imagine with conventional processes, it would be impossible to make an internal lattice, so that's one of the main advantages of additive. So again, the idea here is that with topology, we could bring that back to a more conventional process. With latticing, we can't. And to show what that process looks like is that, again, we have our conventionally manufactured product, and again, we want to apply our loads and constraints to it. Rather than looking at the outside shape or the outside form, we want to actually change out the interior cells of this component. So you can see that after we apply those loads, the lattices inside of the part will vary in weight, will vary in their thickness to where it needs to react to loads or where it doesn't. So you can see, again, this is something that a team of engineers probably wouldn't have thought of making in the past as well. So all of these ideas lead up to the generative engineering idea, where with topology optimization, we put in our loads and constraints, a certain mass that we would like to achieve, and we get a single result. With lattice optimization, it's the same thing. So we put in our loads and constraints, we change the internal lattices of a component to reach a certain result. With generative, we want to apply that same thought process and then result hundreds or thousands or even more products that fit the need that you have. So the workflow is very straightforward. We need to start with a geometry or a volume that we know that we need our part to fit in. We need to then, again, apply our loads and constraints and then the objectives for the part. So let's say we want to reduce the mass and keep a certain factor of safety. We then can put in some information on the additive manufacturing process, such as the orientation that we want our final part to be made in, the minimum feature size, and then we can put in the final material result that we would expect again. So then if you take a look at the part that we have towards the center here, and then we look at what we can get from the generative process, we can get tens, hundreds, or thousands of products that would reach the requirements that we need that are drastically unique from the part that we had at the beginning. So really the second piece to this is the process optimization. So again, we can't just put all this intelligence into our products, make these very unique forming products without knowing how to make it. So that's where the process optimization comes into play. So with process optimization, we think that there needs to be an entire workflow for the additive process that includes everything that we just talked about, so topology and lattice optimization, included with information on the additive process, running a sim on the additive process to know that your final product will fit within the tolerance for your part. So we'll cover each one of these pieces here shortly. So the first would be importing any 3D CAD information you have. So whether it's from Inventor or Fusion, or really any 3D CAD information that you have can be brought into our 3D printing workflow. From here, again, we need to optimize our product for the additive process. Again, additive allows for lattice structures, so we can change out the internal lattice of a part to make it optimized for that. We need to then repair and edit. So if anyone who does have experience with 3D printing, you know that you need to make a watertight model and a few other considerations. Here we can do that, but we can also put in knowledge on the configurations for our hardware. We can put in knowledge for supports. So especially as we start looking at applying additive manufacturing for more complicated materials, there's a lot of inherent knowledge that we need to add for how to apply supports. So using a lot of the techniques here, we can apply those effectively. And then I'll show later how we can close the loop on making sure that those are actually successful long term. So then the third piece, and something that's very critical, again, we talked about how additive can be significantly more expensive than a lot of other processes. And again, we're applying a brand new process to production. So prior to pressing print, we really want to make sure that the final object that we're printing will fit within the tolerance that we would expect. So we can actually apply that here as well. So we can look to see how the additive process will affect our part. Will our part warp? Will our supports fail? And then we can bring that right back into the support creation so we know the right way to create supports and the right way to create our parts as well. And then again, as we look at more and more complicated materials with additive, we typically need to combine additive manufacturing with maybe some other processes, like in this case, subtractive. So I use the example with additive that we can't additively manufacture a threaded hole, for example. So in a lot of cases, we need to combine additive with subtractive processes, and that's the entire workflow that we were talking about here. So there's a little bit more that I could show, but I do want to move on because we are running out of time. So we have a virtual reality presentation now. And is there any questions on additive manufacturing? Yep. Mm-hmm. Yeah, so the way that we have it now is that the material would just be one of the inputs. So we don't have the knowledge in it yet to say that you should recommend another material. That is where we want to get on the generative side of things, which is now we're using that really only with additive, but we want to use that with more than just additive, with subtractive, with a lot of other processes, and also more than just a single material. So in that generative example, I highlighted 5 materials that it solved for. So you could even do 10 or 15 and then look at all the comparisons for the range of materials that you select. Yeah. Thank you.
What's that? So I got this one. Test, test, test. Hello. Can you hear me? No. Okay. All right. Nope, but yep.
Tell me what.
And action. Oh, sweet. All right. 1 for 1. Actually, 1 for 4 today. All right, so how's it going, everybody? My name's Dave Tyner, and I am an immersive technology solutions architect here, trying to basically take your giant data and cram it into VR, the little VR box that we have available to us today. So I'm going to talk about sort of what's the problem we're trying to solve and what is VR. Well, not just VR, but immersive technology. What does it mean? What does it mean to you? And just show you some examples of what we can do today and what some of our customers are doing today. Give you some ideas, answer some questions, hopefully spawn some questions from you guys about what you're trying to do. Is everybody using VR in some form or fashion, whether it be testing or in production right now? Yeah? Yeah. Okay, so relatively few of you, so that's good. You mind if I just ask what, is it production or is it just testing R&D right now? Testing. Yeah, testing R&D, okay, yeah. I mean, that's just where we are perpetually. It seems like space is moving so fast and all kinds of new players are coming in with all kinds of new features, and yeah, it's interesting. So let's jump in. All right, so what I do is I not just, we have all these tools, right? And it seems like our customers are on one side of this this gorge, and we're on the other. And rather than showing you how you build a bridge, we just throw you a bag of tools. We're like, there you go. Go for it. So, so what we need to do is show you how to use the tools properly. So in this example, not the most efficient use of a ladder, but it's solving the problem. Because doing so, the AR and VR space is, everybody's into it, everybody's doing it. So it's not that you do VR, AR anymore that's the differentiator. It's how you do it and what you deliver your customers. Or not just your customers, but internal processes as well. What are your gaps? What are the problems you're trying to solve? Because if you can leverage immersive technology to solve them in a really interesting way that you'll see some of our customers are doing now, those are going to be the differentiators and create big opportunities for you in terms of work and money and job satisfaction, like all the things, right? Because it's fun, whatever. It's fun to do. And why not? Why can't it be fun and valuable? Okay, so yeah, so I'll just do a little soapbox here. VR is a nice to have. It's a pretty picture machine, has no real value outside of entertainment. It's hard to do, it's expensive, and it's only supported in Revit, and you have to be an expert game making person. All of those are false. Again, it all comes back to what are the problems you're trying to solve, right? Because that will dictate the expertise needed, and are there tools available today that help you do that in a couple clicks of the mouse. Regardless, you're going to have to learn something. That, there is a learning curve depending on what you're trying to do, but for a lot of things, that workflow can be pretty quick and pretty painless relatively. Okay, yes, and there's a lot of information out there about VR, and it's all subjective to what you have heard, what you know, what you maybe have seen, and because everybody's on board with it. Everyone is like, yes, this is VR and AR to me, like VR Matrix, AR, that movie I can never remember the name of. Yes, thank you, Minority Report. I always think it starts with an A, so I just go that way. Okay. So yeah, so you think that and you're like, yeah, okay, let's do it. This is awesome. But then it's like, okay, start researching from the software side, and the first thing you do is you hit this, right? And it's like, okay, well, we don't play games here. But as awesome as these games are, there are industrial applications, of course. So then you start looking into the hardware. Okay, now we know the software is there. What about the hardware? There's the Oculus. There's the gear. And what are the use cases? When would you use one versus the other? How much do they cost? I've heard, people who we go around and we talk to, they're shocked that one lady is like, how much does this cost? And I said, well, it's like $3,000 everything for an okay system. And she says, I thought it was $30,000, right? It's like, no, it's $3,000. And but she heard that, so that's the perception she's carrying around, right? So anyway, what are the costs? What are the use cases? When we use one versus the other? And then you have those things, and then that, and then this thing on the market, and then the daiquiri, and that's not the Pimax, but it's like the Pimax, and then the HTC Vive. So a lot of noise, right? A lot of noise out there about the hardware situation. We go with HTC Vive because it offers superior tracking, period, end of story. You can make the Oculus sort of work, but HTC Vive is going to track you in your space, decent sized space too, pretty flawlessly. Depending on the amount of reflective objects you have around the room. There are some asterisks. But yeah, so we go with that. And then we can talk about the mobile use of VR and all that later. But for heavy data, right now, you need a decent machine and an HTC Vive. Also work with the Oculus. All right, so that's cool. So what does it mean to your business, right? What is VR? Because it's like this new thing and it's highly conceptual, but really what it is, it's the same thing you've always done. It's your data. It's your data in context. It's just one more layer, but it's everything you've always done. It's your same work processes. It's the data is king, right? Totally. You can build an entire building from the data, but if I give you the geometry with no data, then there's lots of questions. So that's where it derives from, and that's what the real value of VR and AR is going to be, driving the experience based on that data and streaming it in and making all those processes as efficient as possible, which everybody's trying to work on, and anyone who's tried knows that it's a tough hill to climb, especially as you start getting into the heavier data sets, the big Revits, the big Navisworks, which is like the goal of everything is to get Navis in VR, but there's a reality to that too. It's pretty crazy. So, but let's look at what we are doing today at least. So if I just click on that. So right now we can stream point clouds into VR, and these are not reality capture to mesh. These are straight up RCP recap point clouds. And it's interesting the way we do it because we're only rendering in your volume. Wherever you are, that is the problem you're trying to solve, and I don't need to be able to see, 1,000 feet away because I'm working right here. So none of that has to be rendered. When I go there, that needs to be rendered when I come back. Everything in my volume needs to be rendered is what I'm trying to say because I'm trying to solve a problem right here, not over there. Right, so then also simulations, so CFD data coming in from CFD. There's a workflow through Max. It's not straight across, but the workflow is documented and it's pretty straightforward. And a guy named Louis Marcoux, who works for Autodesk, I don't know if you guys know him, but he's like legendary. Anyway, he put this whole thing together, and it's pretty awesome. Shows this commercial industrial fan with all the, you can change the settings and watch how those settings affect the simulation, and that's all done with real CFD data. Construction 4D scheduling, right? Totally possible. This, I will admit to you, is fabricated. I made an animation that that did it and made it look like it. So, but I'll show you the real deal in a second. It looks a lot like that. Infrastructure data, of course, coming from Infraworks, and being able to really quickly show that data in VR. Not just the data, but we can now also animate trains on train tracks right from Infraworks data with no special animation happening in Max. You just have this plug-in, point to it, you got trains on the tracks. We can do the same thing with cars and pedestrians on roads here pretty soon. Like we can do them now, but it's weird because everybody's going 60 miles an hour around curves, and it's it's interesting, like just right from the data. So that's what I'm saying. All that stuff lives in the data, and we should be able to leverage that, take all the button clicks out of it as much as we possibly can. And then, of course, plant data coming in. That's really interesting, too, because although this is an exported FBX baked level, A, you see it's multi-user, which we'll get to in a second, but B, all of that stuff, I think, we can't do it now, but in the very near future, it's just SQL queries, running, hitting it, and spawning all the pipe, all the equipment. Like, why not? All the data's there. It's BIM, building information model. We should be able to build based on the information in the model. So we're working towards that, but at all times for industry and creating relevant functionality. So there's that. And then also this, which is, again, the multi-user scenario. So now we're collaborating. Anybody, as long as you're on the same network right now, at least, anybody from anywhere can connect. So from the job site to, your high-value centers to the US, right? As long as you're on the same network, you can be collaborating in real time with your data. So you bring in the point cloud, you bring in the design data, and you bring in all the stakeholders to the same place versus, scattering them, flying. And it's all you're all just trying to make a better decision faster, right? That's what we're trying to do. And so we're trying to make the tool to enable you to do that. And then the big one here is this is the real 4D construction scheduling. So this is all being driven from I think it's called Synchro. Anyway, the customer just gave me the data, and so you can see we have this wheel, and you turn the wheel, and it animates each object according to its schedule, and the date you can see is dynamic. And we're bringing in all kinds of BIM data. And what's awesome about this is that not only are we bringing in that data, that schedule and cost and all those things, but all those ugly tabs on the left, they all correspond to a data field. So you're standing there and you say, oh, I just want to see the floors. I just want to see the pipes. I just want to see this. I just want to see the pipes on level 5, right? So it's your data in context, the contextual spreadsheet, more or less. Not having to guess at what that means to the project, but seeing the results of that straight away. Oh, man. That's not exciting enough? It's pretty exciting. Okay. Right. And so it's all the same thing. We're trying to do the same thing we've always been trying to do, which is increase quality and efficiency. lower costs, so we can win more work, so we can make more money and have jobs and all that stuff. So, right, so then that's pretty neat, and those are all data sets that I put together now, and I've been doing, Max, came from industry, but I've done Max for a long time, and I'm good at it. So what does that mean in terms of workflow for you? It's, we're constantly refining. Has anyone heard of Live, Revit Live? Yeah, okay. It's, okay, you haven't seen it. Well, I don't have a video of it, but basically, if you're a Revit user, it's an add-in for Revit. It's a service, so you're all EP customers, you have tokens, and you press a button, it sends your data up to the cloud, does all of the conversion necessary, all the materials, all the optimization, and downloads a live file for you that you can open up in the live editor and click a button and you're in VR, and your project looks pretty good. Asterisk. So the size of the file, right? You can't send a humongous Revit project yet. And there are no hard ceiling that I'm aware of, but I just know that they get too big, it fails, and you have to go back, and it's a little bit frustrating. So there's workflows to get around that in terms of 3ds Max, which everybody's like, no thanks to that black hole. But truthfully, if we can automate the process to the point that you just have to open Max, press a button, and it does all the same stuff that Live's doing, except it does it locally and through Max scripts, but you don't have to watch it. It just spits out a thing that you open up Stingray, which is our game engine, and all your data's there. Awesome, right? I mean, you can open Max and press a button, and yeah, that's cool. So that's what we've done to fill the two big pieces, right, which is how do you get your data in, first of all, which is can be a marathon in itself, and then once it's in, what can you do with it? So you want to create functionality, and it's value-added functionality for whatever the problem is you're trying to solve is. And so those are two really big pieces that we're working on making easier and or creating standard industry-relevant functionality that lives in the product that you just drop in and it just does things. And that's all coming up. Stingray, if you're not familiar with it, is our real-time interactive engine. I won't say game engine, I'll say real-time interactive engine. And it's becoming this product called Max Interactive, which is going to be not an add-in, it's separate from Max, and I haven't got the script on how I'm supposed to explain it. That's just how I know. It's like Stingray. It's exactly Stingray renamed to Max Interactive. That's all we need to know right now. And it's the same thing. So you can, in Max, you can take your models, send them to Stingray, check them out. If they don't work, send them back to Max, add a thing, do a thing, change a material, send them back to Stingray. You don't have to export, import. That just happens automatically. So pretty neat, and that's what I try to do is make the solution scalable, make it repeatable, because why would you just want to do things one time? The design changes, you need the experience to change with it. So right now we have so zero prep point clouds. So you get your RCP file, point Stingray to it. This is not available out of the box. It's a plugin. Just reach out to me or your CSM specifically, actually, and I'll help you implement that. We can get really, really, really large Revit files now with this FBX streamer. So basically, you bring everything into Max, push out this giant FBX. We have a routine that'll run and break it apart into its like little bits. So every nut, bolt, washer, along with all of its BIM data, is available in the experience. So you zap it and you see the data, which is pretty awesome, except that it all renders in your local volume. So wherever you go, it's like the point clouds. The geometry renders where you are, but it doesn't worry about where you're not. And that's, again, it's dynamic. So while you're in the experience, performance is okay. You just tap the button a couple times and builds out. If it gets like weird, bring it back. And until we can, until there's some perfect solution, We're not going to let perfection become the enemy of good. And if it solves the problem, right? If it solves the problem while you're in there, perfect. Occlusion culling, we don't need to get into. Access to any data source. So as you saw from the videos, right, the scrolling of the wheel dynamically reading an external data source, and any data source. So it can be a website, it can be a database on the web, you name it, you reach out, pull the data in. It's what you do with that data that's the big thing. And you want to try to make that as the framework for that as stable as possible, because things change and fields change, the number of fields and all of these things depending on the data source. So got to take all that into consideration. And again, I should say that sadly, none of what I'm showing you is out of the box stuff. I'm just showing you that it exists and it's possible to do. And this is the part where I say our consulting team will come in and help you do it. But I'm not going to say that out loud, so you can't make me. No, I'm kidding. They do a good job. But this is all stuff we've developed. They'll help you implement it, get it, tie it to your systems, make it work the way you want. All right, and so this is a Forge video. So the really exciting thing, and I don't know if anyone went to the AR/VR kit for Forge last night, but we can stream data from the LMV, from Forge, into Stingray with no preparation at all. Just press a button. So long as you have the URL and the links hooked up, your geometry will come in right from LMV right into Stingray. Completely prototype, and there's a lot we need to do, but making that connection so that data's coming in, huge first step. So, okay, so before I move into the success stories, any questions so far? Yes, sir.
I think the big challenge for some of us has to do with not only collaboration with our clients or companies, boards of directors, but also just trying to document all of this. You know, putting it on a drawing, you can't put a point cloud on a drawing. You have to somehow create geometry out of that cloud and to make it work. That for us, if we're building the manufacturing work cell recap, Remake maybe does it, but we have to build that model in order to document it on paper. So I think that's a challenge for a lot of us, is trying to figure out how we're going to collaborate, how we're going to send this information, how people are going to view it.
Yeah. I know. Which is...
That's our biggest.
Yeah.
One of them.
Yeah, I mean, you can do that. You can convert the cloud to a mesh with relative ease, depending on a lot of things. But
those of us that think in the room use Inventor, a lot of us, because of the factory design aspect, so we don't use Revit as much. All the attention really goes to Revit nowadays, it seems like. But we have the same issues. Well, we do everything in Inventor that is done in Revit. It's easier for us to do it.
Sure. Yeah.
But
I mean, and that's great, which is why that 3ds Max solution will work.
Yeah.
Wait, time.
And that's where it's also, like, Inventor and Revit actually work pretty well together. They're pretty good about recognizing families and that stuff. So it's one more step,
people
but it's
call
not.
us to make things to put in Revit.
Yeah. So you could go through
It's
lives.
easier to build in Inventor.
Sure. Right. Yeah. Okay.
And in Inventor, you can create drawing of a mesh. Now, of course, for meshing, a point cloud depends on the sides as well.
Yeah, definitely. You can do that meshing. You can do that meshing in Remake is gone, but exactly. And now it's Recap Photo, but you can do that same meshing in regular Recap now if it's a structured scan. There's some size limits, but if it's like a cell, it'll be well within that 30 meter on a side cube. 100 feet is reasonable. Yeah.
All right. So real quick, thanks. Oh yes, sir.
Just a quick question: is augmented reality going to play a role also?
Oh yeah, for sure.
Okay.
Yeah. We're,
Went out over VR, you think?
Oh.
I see more application with AR than I do VR.
yeah, so depending on the use case, I think AR is going to be huge in construction.
So we're trying to eliminate drawings.
Yeah,
We are trying to eliminate the drawings, we still have to produce them,
right.
but we want to give our people on the shop floor an AR
Yeah,
approach,
completely.
not a VR.
Completely. Yep. And as the hardware improves and the technology improves, we'll see more and more. But right now, that's a big load to try to stick in a computer like that big. But and plus, the experience in AR, specifically the HoloLens, leaves a lot to be desired in terms of what you actually see in there. But everybody loves it, so that's great. And the new version of Max Interactive will support that, the HoloLens, yeah. And we have all kinds of stuff coming up. So, are we good? We're good for like a couple more minutes?
2 minutes.
Okay, 2 minutes. All right, Skanska. They knew nothing about VR. This is Jeff Courtney and Kelsey Stein, who you will see tomorrow. And this is a little bit of a spoiler, but they created, last year, we taught a class, they created this templatized system that allowed hospital staff to, for their pre-construction group, so to get in, configure the room, see the cost associated with the configuration changes that they're making, all in real time. So the owner-operator's in there, they're doing their thing, they're configuring the room, they see the cost, nobody else is involved, they're making the decision, they're comfortable with it, they know approximately pretty close what it's going to look like. And it solves so many problems with the back and forth and the ideas and the renderings and everything. It's really disrupted the way that they do things. And now they've added multi-user, so they can have a Skanska person in there with the owner and showing them in context how to go through the experience, standing off to the side while they do it, and or have another person come in to do it, to do the thing with them, so that everyone can look at it and make decisions. They see the cost. You can't see that cost sheet. It'll come up eventually. But yeah, there's a cost sheet that cycles through every change they make and how much it costs. It's pretty amazing. Dang it, I can't show this next slide. I just found out. But they've won hundreds of millions of dollars worth of work, 5 out of 6 of the last pursuits with this system, and it's simple and it's repeatable, and they can train anybody on it in an hour. Like it's really basic, but their customers are fully into it, and they're differentiating, and then we're working on 2.0 of that. But yeah, it's pretty incredible the success that they've had, and I'm a little bit surprised too, but it's amazing. So. Yep, so that's going to conclude my segment. Happy to take any questions either now or later if you have some. And thanks for your time. And our illustrious leader, Alessandro, I think he's going to close it off.
Thank you. Great question so far. If you have any additional question now, or we will be around in case. I want to thank you for being here, for having preferred us to our CEO. We are very proud of that. I don't know about him, but thank you very much. And again, any final question for any of the presenters? Or yeah.
Dave, about 5 or 6 slides back, you showed one that it was a virtual tour. It looked like from a Revit model, but it looked like it had a fan deck of materials. Can the user actually step into a model with a Vive and change material?
Yeah, definitely. So, yeah, okay, I know what you're talking about. This one.
Right.
Yeah. So this is a delivered template we have that allows you to do that. In fact, in the default Vive template, there's a palette that you can choose and change colors on things and change materials. What you would need to do is either drop your data set into that template in another level, and then you just have that functionality. Make sure you're spawning the palette in. But yeah, as long as your thing you're zapping has physics on it, which means that a ray can collide with it, then the functionality will just take over.
Can you give me a hint how we find that template?
Yeah, it's just default Vive. So we create a new template in Stingray, Vive, you have it. Yep.
And what's the limitations on where the actual physical users have to be for a collaborative work like that? Could you have them in 2 separate locations loading the same model?
Oh, yeah, completely. I mean, that's the purpose, is make sure everyone can connect from wherever, as long as they're on the same network right now. And I don't know if that's the subnet or what that means, but same network, important. Yeah. Good question. And you can also have, by the way, 2 people in the same space in a Vive. So if you have 2 headsets, 2 computers, 1 set of lighthouses, you can have 2 people in there. The risk of collision goes up, but it's possible.
The question? No? So we are perfectly in time. I live in Switzerland, so I'm very happy about that. So thanks again, and I hope it was worth it.